What's up, team? Today we're talking about 45, 45, 90 triangles. A 45, 45, 90 triangle is one of the special right triangles. You'll see a couple of them in other videos later on. The one we're going to focus on today, 45, 45, 90, not very creatively named. Basically, it's just describing a right isosceles triangle. So think about that, right isosceles. It's got to have that right angle, and its two base angles have to be congruent. So if we look at a picture, these are all right isosceles triangles oriented a little differently. Notice they all have a right angle, and then their base angles are congruent. We know that these angles need to add up to 180 degrees. So if we have 90 plus two of the same thing, those same things must be 45. So that's why we call these 45, 45, 90 triangles, because these two angles are 45 degrees, and the other one's 90. That's true with all four of these triangles on the board here. Okay. Because they all have the same angle measure, we know that they're all similar by the angle-angle criteria. We've studied this previously. So it doesn't matter what size these triangles are, we know that they're similar. And so something we're going to explore today is the ratio between the leg lengths as well as the length of the hypotenuse. And we're just going to see if we can find any similarities. So we're going to lean on some previous skills that we've developed. Pythagorean theorem, surprise, surprise. We're still working with Pythagorean ideas as we study triangles. So let's look at this first one, and we're going to take it, look at it the most easy way possible just as we explore some ratios. So stick with me here. If this triangle, let's say that it had leg lengths of 1, easy number to work with. Also, we know that they're the same because it's an isosceles triangle. So these leg lengths must be congruent to one another. What I'm curious about is the length of the hypotenuse here. If we have two legs with length of 1, how long is that hypotenuse? This could come into play if we want to find the perimeter or whatever the case may be. But for this, I'm just curious about the hypotenuse. So I'm going to throw it into Pythagorean theorem. A squared plus b squared equals c squared. It's not going to be very fancy. A squared plus b squared equals c squared. Sweet. I know 1 squared is 1. I know 1 squared is still 1. You add them together, you get 2. So now I have 2 equals c squared, meaning that c equals the square root of 2. Okay. So as far as ratios go, I know that if I look at the leg A, let's call it leg A over leg B, it's going to be 1 over 1, which is 1. Fine, not very interesting. But what is kind of interesting, if I look at the length of the hypotenuse over the leg length, so let's do, we're just going to tuck it down here. The hypotenuse over the length of legs A or B, it doesn't really matter, they're the same, it's going to be true all the way through. What we end up seeing is that we get root 2 over 1, which is the same thing as root 2. Now, root 2 is an irrational number. It comes out to be like 1.41, blah, blah, blah. Not super important right now. Root 2 is what I want you to see for the time being. So the ratio of the hypotenuse to the leg length is the square root of 2. Okay, fine. Let's make this a little bit more challenging. Let's look at something such as, I don't know, leg lengths of 12. And we're curious about the length of C. Same process, the numbers just get a little bit larger. So we're going to see 12 squared plus 12 squared equals C squared. Well, we know 12 squared plus 12 squared is 144. 12 squared is 144, and you double that, and you get, was that 288? So 288 equals C squared. C equals the square root of 288. Okay, fine. How does this, nope, not there, equals square root of 288. Well, if you remember how to work with radicals, I know it's been a minute, so I'm going to show you real quick. If we take this 288 and make a factoring tree, we can break it down as 2 and 144. We can break that down with 12 and 12. And from here, what we know we have here is we know that 12 times 12 creates that perfect square. So if we're going to simplify this radical, we would get 12 times the square root of 2, because that's what remains here. Gosh, if you don't remember that, that's a lesson for a whole other day. Look at simplifying radicals. You might have seen it on Khan Academy or something like that. We haven't studied it in geometry. That's an algebra topic from previous years. But trust me on this one for the time being. So you'd factor it like this. When you find a pair, that's what goes on the outside, and whatever's left over ends up on the inside. So we end up with 12 root 2. Okay, cool. Let's explore this same ratio, the hypotenuse over the leg length. And what we find is we get 12 over root 2, that's the length of a hypotenuse, over 12. And when we cancel that, or when we simplify this, we have 12 over 12, that's 1. So we end up with root 2 over 1, which is root 2 again. That's really cool. So it seems like what's happening here is if you have the length of one of your legs and you want to find the length of your hypotenuse, just multiply it by the square root of 2. So far, it's worked for us twice. That's cool. That's cool. Let's look at one more example just to further convince you, and we're going to get a little bit weird with it. Let's say in this situation, let's erase some of this work. It's all still true. It's just in the way. We have leg lengths of pi. We want to find the hypotenuse. Yuck. So pi squared plus pi squared equals c squared. Okay, so we have 2 pi squared equals c squared. I'm going to throw the little multiplication sign here. So what I'm going to do is I'm going to treat this one a little bit sneaky. I'm just going to take the square root of the left side and the square root of the right side. So what this left side turns into is the square root of 2 times, well, the square root of pi squared is just pi. And then on the right-hand side is just c. So if I rearrange this, I get c equals pi root 2. So we have an irrational number times a rational number. Sweet. But what we're really interested in is this ratio. Again, so we have the hypotenuse over the leg. Hypotenuse over leg, I'm abbreviating here. The length of the hypotenuse is pi root 2, and the length of the leg, well, it was given it was pi. Again, cancel, and you get root 2. So this ratio maintains no matter how long the leg lengths are, or how irrational or weird the leg lengths can get. So from this, we can say in general, if you have some leg length x, it doesn't matter what it is. It can be 1, it can be a million, it can be something in between, or something bigger, pies, fractions, decimals, whatever you want. If you have that leg length and you want to find the length of the hypotenuse of a 45, 45, 90 triangle, again, this is specific to the 45, 45, 90, all you need to do is multiply it by the square root of 2. So whatever that x value is, again, it can be 1, it can be a million. All you need to do is multiply it by the square root of 2 to find the hypotenuse. And the same is true if you want to go the other way. If you have the hypotenuse, divide it by the square root of 2 to get your legs. Okay, I'm going to pause this. We're going to look at 2 examples real quick. Hang on. Okay, I said we're doing 2. I'm giving you one for free. We're doing 3 of these. Okay, so over here, the first one. We have some leg lengths of 11. We have an unknown leg length, and we have a hypotenuse of length c. I want to figure out what the length of A is and the length of C is. Let's look at A first. Way easy. We know this is an isosceles right triangle. Isosceles triangle, the legs are going to have the same length. So we don't even need to do any math. We just know that they're the same. Cool. Now, for C, we could do the whole Pythagorean theorem, 11 squared plus 11 squared equals C squared, and solve, like we did just a minute ago. I don't want to. Let's use our shortcut. This is still here. So if we know we have a leg length of, in our case, it's 11, all we need to do is multiply that by the square root of 2. So C is 11 root 2. Technically, you could call that done. That is the most precise answer. For me, I like to explore the decimal approximation. I have a hard time understanding what 11 root 2 is. I know root 2 is like 1.4-ish, so this is like 15-ish, but I want to throw it in my calculator. So I'm typing in the square root of 2, square root 2 times 11, and I get 15.56. Now, again, if you left it in radical form, technically that's the most correct. I like to see the decimal approximations. Other math folks are just a lot more picky, and they want to see it in radical form. And again, sometimes it's easier to work with in radical form. So I'm going to let you decide how you want to do it. In my solutions guide, I have the decimal approximation. So you can check your answer that way. Okay, next one. Here we're given the hypotenuse. We know it's opposite of 90. We want to find the A. We want to find the B. This one, we don't actually even have to do any calculating. We know the hypotenuse is something times root 2. Well, in general form, hypotenuse is something times the square root of 2, where that something is just the leg length. So for us, this leg has length 16. This leg is length 16. Done. Special right triangles. Pretty cool when we can use these shortcuts. Okay, last one. This one's going to be a little bit trickier. Again, we're going to use a calculator. We want to find the leg lengths. Foreshadowing a little bit, they're going to be the same. So we're going to solve one of them and just copy the answer over because they must be the same. So to find A, hypotenuse is length 17. So that means Hypotenuse has the same value as x root 2. Okay, well, we're interested in the x value. So let's set up an equation here. So we'll say 17 equals x root 2. Again, solving for x, we just need to untangle this mess. This is x times some number, gross number, but number nonetheless. So we're just going to divide both sides by the square root of 2. So on the right-hand side, divide by root 2. On the left-hand side, divide by root 2. These cancel, that's the whole purpose. So now we get x equals 17 over root 2. Again, I want to see a decimal approximation, and of course, as a radical in the denominator, some folks are really picky about that. I'm not. That's just me. So let's type in 17 divided by the square root of 2. So 17 divided by 1.5, gosh, this is going to be 10-ish, 11, 12, something like that. And it gets, 12.08 is the decimal approximation. Or sorry, 12.02. So that is our A value, and our B value is also 12.02. Okay, sets of right triangles, 45, 45, 90s. We're going to explore a different one in the next video. This is the general form. This belongs in your notes. This belongs on whatever resources you're using when you take the quiz. But more importantly than having it is knowing how to use it. Dive into some practice problems. Ask me all your questions. Here we go. You got this.